Welcome to the second day of the American Gem Trade Association's Dynamic Seminar Series, sponsored by the American Gem Society. Thank you. Elizabeth West is a skilled gemologist and passionate educator with over 18 years' experience working within the jewelry industry, specializing in diamonds. As a fellow and diamond fellow of the Gemological Association of Great Britain, and a member of the Federation of European Education in Gemology, Elizabeth has worked across varying roles, encompassing auction house specialism, museum curation, and advanced gemological testing and grading. She now focuses exclusively on diamond education, recognizing the vital role it plays within the industry, from instilling confidence to driving positive change. Based in the UK, she has worked for De Beers for 7 years, creating educational content and running in-person events and workshops to encourage a deeper appreciation of natural diamonds, a subject that grows ever more beautiful the more you learn. Please give a warm welcome to Elizabeth West.
Thank you to my small yet select audience. I'm very, very grateful for you all turning up at 8 o'clock in the morning to see me. So I hope that you enjoy the next half an hour, 40 minutes or so. And thank you very much, Gary, for the introduction. But I should possibly start this presentation with just a reminder that as much as I'm proud of all my affiliations, I'm standing here this morning in front of you as a gemologist who is passionate about her subject and who has spent the last 20 years as a dedicated student of diamond. But here's the thing. I have often wondered why. Why diamond? In fact, why generally? Why over the course of 2,000 years have we elevated the diamond to status of queen of all gemstones? And that's what this presentation is about, because I think I have come up with a little bit of a theory. So let's start with what defines a gemstone. The word gem comes from a Proto-Italic term which is gebma, meaning bud. So that already suggests that thousands of years ago, we were romanticizing the natural origin of the gem as this bud blossoming from the depths. And I think Pliny the Elder possibly said it more succinctly when he said that the crystal is the supreme and absolute perfection of nature's work. So for thousands of years, we have marveled at their creation, when temperature, pressure, chemistry all align and a crystal grows. And as a species who craves that connection with nature, we are invariably drawn to the gemstone in the same way as we gaze at mountains or beautiful sunsets. I had my first Tucson sunset last night, and yes, it was special. We are in awe of nature's ability to render the world perfect and beautiful. And all that a gem ever symbolizes evolves out of these natural qualities. We have ascribed these qualities, connecting them to some of the most profound human emotions. And the same stands for diamond. We have celebrated for its hardness, its adamas, from the Greek, meaning invincible, unconquerable, for its first water transparency, for that perfect crystal form, and all of these things came to symbolize symbols of strength, fidelity, beauty, status, and of course, that enduring bond between two people through thick and thin. But to get to the point, there is something more to diamond, something that sets it apart just from its beauty. And this is what circles back to this idea of connection. So possibly the best way to explain this is, if you will allow me, is to take you on a little bit of a journey. And it starts with a single point in space, no larger than a pinhead, 13.8 billion years ago, when everything we would and can ever become was consolidated within it. All form, all energy, all matter. That point, in an irreplicable instant, exploded, expelling into space an unfathomably hot mass of matter to expand in a chaotic fury. And in the next 100 seconds, the temperature tumbled, and nuclei of hydrogen, that's one single proton, and its offspring, deuterium and helium, emerged from the chaos. And in the next 17 minutes, our universe was born. A beautiful dance of gaseous clouds and the vastness of space. But it was dark. It would take 100 million years before, in the densest regions of those clouds, those hydrogen atoms fused, releasing energy in the form of light and illuminating the darkness with those celestial bodies we know as stars. Now, stars, those bright, beautiful, distant points in our night sky, are the birthplace of all known elements. So that's that invisible array of atoms that goes to constituting everything around us. So let us take ourselves back to that infant universe, when in the extreme heat in the heart of stars, through a process known as nucleosynthesis, the most basic elements were forged. Hydrogen fusing with hydrogen to create helium, helium in turn, beryllium. But where next? It is a remarkable trick of chemistry that facilitated the following steps. A fortuitous quirk in the resonance, so that's that marriage of energy states that allowed that fragile beryllium nucleus in less than 10 to the minus 16th of a second before it itself decayed to grab at a roaming alpha particle and create carbon. Carbon. The element that would be the catalyst for the synthesis of all known elements beyond it. Without carbon, nothing heavier can exist. No oxygen, no nitrogen, silicon, magnesium, calcium, iron. No rocks, no planets, no air, no life. So this is where our story truly begins, with carbon. Because some of those atoms, dredged from the outer envelopes of exhausted stars, found themselves dancing in the stellar winds around those stars. Those atoms, released from the atomic fury at the core, but fueled by the extreme heat, were able to bond in tiny tetrahedral arrangements. Perfect crystalline structures of the pure form of carbon, which we, in celebration of its strength, would come to christen as diamond. The hardest naturally occurring mineral on the planet. And plausibly, actually, indeed, pretty much possibly, the first mineral to have formed in our cosmos, seeding space with possibility and connecting us to the very birth of time. But stars, as the womb of all matter, must relinquish the child. In the larger stars, the energy required for the synthesis of the heaviest elements, iron, exceeded the energy generated by that fusion. And the result? Well, gravity won, and the star collapsed in a powerful supernova, expelling into space all those carefully forged elements that it had been creating over the course of billions of years, including carbon. Those elements fused to become tiny crystalline particles of matter, or stardust, lost in the nests of nebulae that inhabit the expanse. And as new stars ignited, including our own sun, that stardust, it became caught in the swirling skirts of debris around that star, fusing to become meteoric masses which grew ever larger as the gravitational pull gained traction with size until it became planets, including our own, 4.56 billion years ago. Now, and I always like to imagine this, imagine our star-forged carbon, locked in the great expanse of our young Earth. Each atom, 1/1,000,000th of a millimeter within 1,000,000,000,000 cubic kilometers of spinning rock. They were like travelers from the dawn of time, caught in the great progressive streams of melt or liberated from the fluids that surged through the depths. And there they remained as wanderers for another billion years, until the crust of the earth slowly began to emerge from the seas. Now, despite the turbulence of our planet, portions of that crust actually survived and thickened to become ancient cratons. From the Greek kratos, meaning strength, preserved by the roots of rock that extended beneath it to depths of up to 300 kilometers. So now I want us to journey into the earth. Because beneath these cratons, within these roots, our star-forged carbon atoms met. And deeper still, in the depths, they found themselves in an extreme environments where pressures exceeded 45 to 60,000 times atmospheric pressure, and temperatures surged between 900 and 1,300 degrees. But that is slightly cooler than the surrounding rock that slowly churns with solid state convection like some great beast stirring in its sleep. But therein lies the magic. Mother Nature's way of ensuring that everything finds its place, everything achieves equilibrium. Because it is in these roots, beneath these ancient cratons, that the serendipitous combination of temperature, pressure, and chemistry allowed our carbon atoms to bond together as diamond. Exclusive regions, precious regions recognized as the birthplace of most of the diamonds we hold, and the waiting room for them all. It is genuinely a remarkable story of resilience. We know that the oldest diamond to have been dated formed 3.5 billion years ago. Our Earth was young. If we track the evolution of our planet from that point forward, we have seen, well, we haven't actually seen, but continents have been formed, they have been destroyed. Oceans have opened, they have closed, and mountain ranges have risen, they have fallen, and they have risen again. Deep in the earth, while all of this was unfolding above them, our diamonds sat as vulnerable witnesses to the earth's slow and momentous evolution, shifting with the ever-changing landscape. But for those that did endure, the greatest test was still to come. In episodes spanning over 1 billion years, but at their most active, in the Mesozoic, when dinosaurs dominated the land, deep origin volcanic eruptions surged through these diamond-forming regions, transporting the gems to the surface from depths we could otherwise never reach. But diamonds, they can easily be destroyed by that magma. For those that were caught in the fast-moving torrent of molten rock, it became a battle of survival. Those diamonds that have made it to us have done so against all odds. They come to us as courageous messengers ready to recount every chapter in our diamond story. And they come to us as teachers, reminding us it is not just the creation of bonds, but their retention that is the true measure of strength. We need to heed their lessons, not least to hold on. But some of those diamonds were sacrificed to time. The carbon that created them was returned to the great repository of the element, which, when it bonds with other elements, forms a great deal of the world around us, both creating rock floors and rock faces, cliff faces, both building and protecting life, and filling the lungs of ancient trees to let us breathe. Carbon is the bedrock of all existence. Everything that lives and breathes requires carbon. You are all 18% carbon by weight. In fact, there is nothing to say that a carbon atom in you wasn't once a carbon atom in a diamond billions of years ago. So I leave you with this. When we first saw these gems, these diamonds, winking in the riverbeds of India over 2,000 years ago, is this what we saw? Did we register this fundamental connection? Diamonds remind us of our origin, when carbon was formed in the heart of stars, then danced as diamond in the pre-solar world. They remind us of our evolution and survival when that star-forged carbon became locked into our planet at the point of our formation, to become its most enduring creation, formed of that life-giving element alone in its purest crystalline state, like the essence, the seed, the bud of life itself. Diamonds signpost our entire existence, from the beginning to the end, with the creation of the element that gave us life, to the fate of the heavens above us. To hold a diamond is to hold our entire story in your hands. Well, that's why I like them. Thank you very much. I hope you enjoyed that.
Well, thank you very much, Elizabeth. Do we have any questions for Elizabeth?
Oh, Matt, of course.
Dad, I'm sorry.
That's all right.
You had shared that diamond started forming 3.5 billion years ago.
13.8 technically, Matt.
Is type 2A, or what is the oldest diamonds? What takes the longest of all the typing? What is the oldest of all typing?
I don't think you could specify a type based on age specifically because there are so many other factors that align in order to dictate that type. So I couldn't say that the oldest diamond, well, the oldest diamond dated was a type 1AAB, sulfide bearing from Ikati in Canada. That's the oldest diamond we have. Yes, you can tell by nitrogen aggregation, that specific pathway, that gives you some level of indication as to the temporal shift of a diamond, but because there are other factors at play that can prevent that aggregation, which dictates the diamond type, the two don't correlate naturally, if that answers your question. And it's 13.8 billion. Oh, but to your point, the stardust, that would have been type 2A if we wanted to work to category.
Any other questions? Yes, go ahead.
Is there any way to sort of predict a possible kimberlite eruption?
There is a lot of modeling underway to look into that, but fundamentally we are still a little flummoxed as to how they form in the first place. And when I say we, the royal we, there are far greater brains working on it. But because we are not 100% sure what mechanism is promoting these kimberlitic eruptions, there's no way of determining when the next one will be. There have been a lot of suggestions that it's linked to tectonic activity. And I know that there's some recent research done by Professor Gernon from Southampton University, which seems to correlate that quite nicely, which could be a predictive model, but I don't think in the broader academic community that's been held onto very firmly. I know that if it's going to be, actually, to be perfectly honest, we don't really want one. I mean, as much as they'd be handy to have a few more diamonds up at the surface, I mean, it really wouldn't go well for us, I don't think. They're pretty nasty pyroclastic eruptions.
In your opinion, what is the most significant difference between a natural and lab-grown diamond?
I was waiting for that. This story, fundamentally. And if you think about what we're doing in this industry, every piece of jewelry from time immemorial is connected to the story or the symbolism that it holds for us each individually. That's what enriches its value. And that is why the natural diamond story is one of its most powerful accolades.
Creation is formation.
Mm-hmm. And the fact that if you think about it, if you really think about a diamond, and you think about its story, I mean, the 13.8 billion year one I've just galloped you through, diamonds are here against all odds. From the creation of the carbon in the first place, that triple alpha process was just a huge quirk of chemistry, to the fact that they were formed well beyond the depth of man. I mean, diamonds form below around 140 kilometers in the earth, right? How deep can we dig as humans? We've managed 12. So we have the diamonds form well out of our reach. They're happier down there. They don't want to be anywhere else. We then have to rely on this huge, very rare, very small, very powerful series of volcanic eruptions. They've got to be in the right place, the right time. Then they've got to survive that journey. bearing in mind that as soon as a diamond's in contact with that magma, and that magma loses pressure, those volatile agents will just go to work on those diamonds, and they will be dissolved. They will be oxidized. So to actually get a diamond up to the surface from those depths, huge feat of miracle. And then when they get up there, they don't want to be here because they're metastable. They're in the wrong environment, but because they're so strong and those bonds are so strong, they are held in place. So they really are miracles as a gemstone. And I mean, I have a lot of respect for the amount of technology that goes into lab-grown material, but I think it's space. It belongs within the industrial space. It can do a lot of good there. But when it comes to representing something meaningful, which is what our industry sits upon, that's what jewelry sits upon, then it doesn't stand a chance. Does that answer your question? God.
Magnificent presentation on the origins of diamonds as the story of creation. And yet that story leads to another miracle, and that's human consciousness, human creativity.
Yes.
So
Yes.
I would just like where you left off to build on why the story of the arising of human consciousness out of stardust, leading to lab-grown diamonds,
Oh,
is not also a dramatic story of
it brings it full circle. It does bring it full circle. There is that. There is that. I mean,
how do you respond to that?
how do I respond to the fact that,
That's also a good story.
I mean, you do have you have a point, but we can't directly correlate that journey of consciousness. As I said in my answer to the last question, I do have a significant amount of respect for lab-grown material. I mean, my journey at De Beers started at Element 6. They're our industrial diamond arm. And I see, talking to your consciousness, I saw the brilliance of the physicists, the chemists, and well, that was about it, actually. But I saw their brilliance, and I appreciated it. But you know what I appreciated more? Not what we've turned lab-grown diamonds into, which is, you know, a substitute for diamond on a lower price range. What the brilliance you're talking about is the brilliance of engineering diamond material with such astuteness that they can manipulate it on an atomic level to create nitrogen vacancy centers, which act as magnetic field sensors, which can pick up cancer at its earliest stages. We can see industrial material that's been boron doped, being used as a semiconductor to break down those horrific PFAS chemicals and purify water. That is brilliance. So if I wanted to tie up that story from where I started, yes, I'd end there. Well, I wouldn't end there, but I would circle back to diamond, because you need to understand the material from its very natural origins in order for those brilliant maneuvers to be taken the next step forward. But thank you. I like that.
Brilliant. No pun intended, sorry. Any more questions? Yes, go ahead.
What's the main difference between a kimberlitic eruption and every other kind of volcanic eruption?
Every other, oh, you mean like a kind of basaltic or a calc-alkaline depth, fundamentally?
So is kimberlite?
It's on a chemical level. The prime differences of kimberlitic material is ferromagnesian, olivine dense, but the its crustal origin, the other, such as your basaltic magmatic eruptions and your calc-alkalines.
So that's deeper than the other layers? Is what's
Yes, I mean, the origins of these kimberlitic and lamproitic eruptions are well beneath, well, they're mantle-derived.
More questions? Without getting too deep into the science of this thing, I once heard somebody talking about plate tectonics and how the carbon on the surface of the Earth then finds its way down to the depths where it can then recrystallize.
Absolutely. Subduction plays a huge role in diamond formation. Huge role. In fact, there's I mean, if you're looking at carbon nitrogen isotope signatures, there is a strong suggestion that maybe not the peridotitic, and it's definitely I needed another coffee, material, potentially not that, but the eclogitic material that relies on the carbon to actually create the diamonds. That's, and indeed the super deep material, which I know that you probably come across in conversations with other gemologists in our industry.
Oh, thank you.
I'm sorry.
Great.
Hence, carbon atom in you could have once been a carbon atom.
Yes, exactly. Yes, over there.
Yes. Could you make this into a commercial?
My marketing team is at the back.
It's in the back. Okay, great.
More questions?
I
If
mean,
not,
I think they got up here and they sat here from 8 o'clock to whatever time it is now. I think everyone deserves another coffee.
well, let's take a coffee break. Thank you very much, Elizabeth.
Thank you.